Well, welcome everyone to CGHE webinar seminar number 347. And we have with us Marek Kwiek again, one of our most popular webinar presenters, and he's going to talk about big data in practice, women and men in global science. Now, it's a pleasure to introduce Marek Kwiek. He's really a very important social scientist in opening up our understanding of science, of knowledge, of research, of cooperation and competition status in research. And he's specialized in doing that in relation to higher education. And in doing so, I think he's carved out a unique, important role in bringing the data forward, in mining it again and again for more and more explanations, discussions, ideas. He's developed an inexhaustible flow of papers, and every one of them, I think, well worth reading. He's a professor at the University of Poznan in Poland. He's had a long-standing presence in higher education studies, many keynotes, memberships of learned committees and associations. I'll let him take over from here. Marek, the screen is now yours.
Thank you so much, Simon. Thank you for this kind introduction. I'm just sharing the screen right now.
Yes, we can see that.
Making sure you can see it, yeah?
Yeah, it's all exactly as it should be.
Okay. Good afternoon, everyone. I'm delighted to be back here. It's always such a pleasure to be talking in this company. Okay, I'll be talking about the application of big data to thinking about science, specifically about demographics in science, about women and men. And when I mean global science, I mean basically the OECD area, where data are rigorous and relatively much easier to handle than the whole world. So global, take it as the OECD area, men and women, but especially women. Okay, it's going to be a somehow exploratory study because I'm just testing the usefulness of global data sources in thinking about well, scholars, scientists, academics. So I'm trying to think in terms of gender, clearly defined, age, clearly defined, also discipline, and the passage of time. So the past 20 years or the past 30 years. Basically, I want to know what we can know using, well, in this case, Scopus data. What we can know. I've been studying academic profession using surveys for, well, more than a decade, and I'm just using new data sources. I'm thinking that traditional data sources are somehow inadequate or somehow powerless. When you look at national statistics, or when we look at aggregated global statistics like OECD or UNESCO or even Eurostat, this type of data does not allow us to say what we want to say. So what is perhaps most interesting or most important is when I'm saying I mean Poznan, our move from papers to academics, or from bibliometrics to what I term global academic profession studies. This is my team, and this story today was prepared with Łukasz Szymula, our stellar doctoral student, leaving for 6 months to Boulder, Colorado, unfortunately, but I hope he will be back. You can see him on the left. And now I was doing a bit of thinking about women in science in the past 2-3 years. You can see just the titles: collaboration, international collaboration, well, by gender, also male, female, or mixed sex collaboration, also what I termed the gender solo research gap, different percentages and numbers of publications written solo, by gender, and finally young male and young female scientists. Well, starting the story somehow in very general terms, my question was, why women leave academic science. Just 2 slides. We know that both men and women leave science. It just happens. But still, we know that women leave science earlier, and they leave science in larger proportions. And that's an issue. There are basically 3 major theories, empirically tested, present with us for a couple of decades. It's the Chile climate theory. Women are somehow wholesalely welcomed or unwelcomed in STEM fields in their institutions. This is number 1 theory. Then self-selection theory, which says that women just are somehow less interested in pursuing careers in STEM fields. And finally, perhaps the most well-known, the leaky pipeline theory, which says that women and men, but especially women, come to science and disappear at every stage of academic career. There's a loss of talent at every stage, and the system allows to leak out women for a number of reasons which have been discussed empirically for a long time. And why it happens, there's a couple of reasons shown in literature. Reasons are for STEM. Some of them work also for humanities and social sciences. Well, it's gender bias and discrimination across different procedures, hiring, promotions, pay. It's work-life balance. As we all know, highly competitive business, long working hours, high pressure to publish, high pressure to secure grants, and at the same time, family responsibilities, caregiving, etc., etc. That's a reason of leaking out of science, one of the reasons. Then role models and mentors, not really too many, isolation of women in male-dominated fields. I'll discuss it with my data in a moment. Finally, barriers to promotion and barriers to leadership, which are called glass ceiling sometimes. And finally, this practical issue like childcare at the university, flexible work arrangements, or missing mentoring programs at the level of institutions. And now, very briefly, I need to say, and there will be 3 slides very briefly about digital traces in academic profession studies, because it's critical point. We used to be thinking about academic profession studies in terms of interviews and interviews, focus groups, and surveys. Now we have new sources, and I'm testing these new sources. Major sentence, most important perhaps, academics leave traces, we leave traces in our index publications. I believe there are no other reliable traces available globally. There are a number of traces and other sources available nationally, but globally we have only these type of traces I will be discussing in a moment. So what I'll be stressing today is the level of detail available. We can measure us, which is the academic profession, with a lot of precision. Really, it was unthinkable a couple of years ago. We can know things and discuss things and theorize about things which we're not even considering, say, a decade ago. Why? Because everyone wants more details, wants it faster, wants it from larger samples. This is the difference between surveys and big data approach to academic profession. What we need to remember, this type of data doesn't come, we don't produce this data. They are not self-produced. They come from corporations or they come from governments. I'm using governmental data and corporation, in this case, Scopus or Elsevier's data. So we need to repurpose the data. We didn't produce them. They were produced not even for us, for different purposes. They are complex, they are enormous. What we can do is we can ask new questions and test old theories, or do both, which we are trying in Poznan, testing what we were thinking 50 years ago and also asking new questions. We just extract useful information, which is a complicated thing, but we can do it. We prefer curated, structured, it means also expensive data, like Scopus Web of Science, but also national registries, Polish Registry of Scientists, all types of CRIS systems across different countries. And what we believe, we have new insight into academic profession available today. Now, What we can explore, just a few sentences. We can explore almost everything. All scholarly activities recorded in publications, metadata, but related to research mission only. There's no way to discuss teaching or other missions based on this data. So it's research mission only. We can discuss research and collaboration and impact and mobility, all using this type of data. And everything can be cut by gender, by age, academic age, seniority, by discipline, and over time, today or dynamically, 1 decade, 2 decades, 3 decades. We can also, perhaps most importantly, and a bit of self-promotion on the right, you can see my paper published 10 days ago in higher education, once highly productive, forever highly productive, a study of full professors. It's a really longitudinal study. So we were following academics over time for 40 years based on their publications. And we are just finishing a study on OECD cohorts. We were tracing 300,000 academics over time from OECD countries, asking generally pretty the same questions. Well, what is our approach in Poznan? Well, as I told you, a transition is needed, and we did it from publication metadata to us scholars, to metadata on scholars. This is one thing, transition. Then another thing is we combine national level data and big data. So we don't stick to big data. I would say we do first approaches and first studies based on national data combined with big data, and then we do the world or OECD world using big data, having all experiences from national level studies. We focus on scientists, certainly, not really their publications. What kind of data we have around? National and global data sets, both. Commercial and non-commercial data sets, both. Some we can buy, some we can gain, some we can gain access to, some we have no access to. We combine these data sets with, well, labor data sets, workforce data sets, administrative, bibliometric, biographic, all types of data sets. And you can see the list of databases that can be used. We use just a few of them. But what is really important is we are working with scholars, and scholars have their attributes. Not papers have their attributes, but scholars have their attributes. So they have gender defined, age determined, collaboration patterns determined, etc., etc. And we work on the combination of these factors, especially in logistic regression models. Now, current story, the global academic profession, men and women. Why was it done? Because we wanted to see what is possible to say on the global scale. Again, global is OECD. We could do global, 181 countries, but the data would be much less rigorous. So let's say for a moment, global is OECD. We're testing how demographic transformations of global academic profession can be measured. How to do this? Because we were somehow dissatisfied, or I was somehow dissatisfied with these OECD, UNESCO, and Eurostat type of data. I'm pretty pleased with Elsevier's data from these two reports you can see here about gender, but still our focus is different. We focus on young women, scientists, STEM only, and trends over time. You can see first approach, first preprint here with Łukasz. It's available from arXiv, but still I'm just revising it for quantitative science studies, second round of revisions. Now, very briefly, it seems pretty technical, but it's not. It says how we were cutting our sample in these OECD studies. We moved from 43 million, that is the whole Scopus publishing universe. We go down to 4.3 million scientists because we use all those filters. We needed gender clearly defined. We needed discipline for everyone. We needed country of affiliation for everyone. We also needed what we termed nonoccasional status, meaning we study only scientists who have at least three publications type article, research article. So we are pretty limiting in our approach. We also need academic age. Well, we do a number of studies for more than a year. We continue those studies. One is about productivity classes, lifetime for all scientists from OECD area as defined here. We also finishing a study about gender self-citation gap. Is it really so that women undercite themselves and men overcite themselves? It is the case in the past 30 years, but in every discipline, STEM discipline, we have it. Also, aging of academic profession. We started it more than a year ago. It's almost finished. So expect more studies in the coming, say, 6 months or so. Now our methodological approach, very briefly. When you think of men and women, we need clear gender determination, and it's done. We also need clear discipline determination, just one discipline, and we do it based on all cited references in every single publication lifetime. It's tiresome. It takes a lot of time, but it's done. We also work with academic age groups. So we have very young scientists, etc., old and very old. So we have 10 ranges when you think about academic age. What we think in the larger terms, we think that changing proportions between men and women are important. Proportions change. It's not so much about numbers, it's about proportions. But the major point is we are working with a special case. We work only with publishing, well, first publishing, not any scientist, but publishing scientists. Then we work with those non-occasional type of scientists, well, at least 3 publications. Then only OECD area, well, only 38 countries. And finally, publishing in Scopus index journals. You immediately see a number of limitations. They are here, Scopus index journals. But we believe there is only a couple of large-scale databases which allow to think globally when we consider the academic profession. I believe it's the only feasible approach today, and it's at the same time cost-effective. Now, very briefly, where women are located, so defined as is in the slide before, where they are, where women are, and basically where men are, because it's the other side of the same picture. You can see that in our approach in the OECD area, publishers and not those non-publishing people, not really higher education people, but science people, publishers, women publishing are located mainly in medical sciences and biochemistry, molecular biology. The 70% of publishing women this year, or 2021, are in those 2 areas. This is kind of surprising, but this is what our data show, and this is what our determination based on cited references tells us. We started 1.4 billion cited references to go down to every single scientist and his or her self-cited cited references to see who they are. Well, you can see when you look at disciplines on, you can see that there are disciplines that I call them the big 4, where there is a limited number of female or small percentage of female scientists. It's engineering, physics, computing, mathematics. It's below 20%. And there are other also STEM areas where there is a lot of women. So there's huge differentiation of where women go and where they don't go. This is perhaps the most interesting or the most telling figure today. It's just 1 year cross-sectional view, 1 year. But all scientists here, 1.5 million, are distributed according to their age groups. So you can see people, scientists from young age groups to very old age groups in every single STEM discipline. And you immediately recognize here, just from the shapes, that in computing or in mathematics or physics and astronomy, but also in engineering, there are roughly the same percentages of women by generation. And when you look at other disciplines, say medical sciences, you see that the younger the generation, the more women are around. And this is perhaps the most important finding. Young women go to some disciplines rather than other disciplines and stay in them rather than in other disciplines. And the big four, this is where young women don't really stay, or come and go, or really don't stay. And now you have just zooming on all scientists. You see, say engineering, and you see how small is the share of old women about old scientists. It's very small. And now how increasing is the share of women among all scientists if we think about, if we take younger generations into consideration. You can see almost half of women today, publishing women, this is the total square, all disciplines combined, half of publishing women, half of publishing scientists are women. But still things are not changing in computing or in mathematics, and that's, well, one of the most telling issue. Why is it happening? Why mathematics, physics, computing, and engineering? Bigger number, but still very, very small. And I was thinking for a long time how to show the isolation of, well, women in science in selected disciplines. And when you look at engineering, one simple example, 1 year today, more or less today, there are 10-time differences between, or there is tenfold difference among the old scientists in engineering, and just 5-time difference among the young scientists in the same engineering. And this is generally the picture. If you look around in our universities, institutions, just 1 year today, you can see the enormous isolation of the old and the oldest, and then a little bit smaller isolation of the young and the youngest. It's still huge isolation, but it's not 10 times, it's just 5 times. We also studied, well, trend over time. We did a linear regression model for the past 30 years. And when you look at the slope, which is, you know, the speed of increases, you can see that the share of women is increasing across the board. But in some cases, and I call these, you know, math intensive big four, computing, engineering, mathematics, physics, and astronomy, the share of women is just small. The starting point is small, and the share is small, and the slope consequently is also small. So we did a purely hypothetical exercise. Let's suppose you have the current trends unchanged. We have trends for 30 years, and we do something we shouldn't be doing, thinking that the trend continues. When there will be gender parity, 50-50 in those 4 disciplines, the parity would be in about 100 years or more. But when we look at just young scientists, we are pretty close in some areas to gender balance, not parity, but balance. And when we look again at young scientists in some disciplines, this parity is even achieved. So it's a hypothetical exercise, but still we see enormous changes going on if we consider trends for the past 30 years. Now, and finally, just 4 slides of summaries and conclusions. Well, global data sets and their limitations. This was my most important point. What we can do and what we can't do using this type of data. This type of data allows us to assess global distributions by gender, important, by discipline, very important, and finally by age groups, which we can't do normally. We can study academic profession cross-sectionally, 1 year, several years, one by one, or longitudinally. We can follow scientists over, well, even lifetime for 20 or 30 years using Scopus data. Then, well, we can study individual scientific careers, but there are limitations. We have to be aware of the limitations, know the scope of limitations, and discuss them. So there is, I call it a methodological price to be paid. needs assessment generally is needed. But still, some algorithmic techniques are necessary. We extract information. We need collaborators. We need computer scientists. We need statisticians to do this. So this type of work is clearly team-based. Finally, apart from the old limitations, we have new limitations. Old limitations of bibliometric datasets are well known. It's English, it's STEM, it's Anglo-Saxon biased. Well, we just know it. We've discussed it for 20 years. And now with this type of studying academic profession, there are new limitations, which I'm showing right now. Well, gender determination. For some countries, it works worse than for others. Discipline determination. We use commercial journal classification from Scopus. Determining country affiliation. We don't think about migration, just one country per one person. Arbitrary threshold for this non-occasional status. Why 3 articles? Why not 2 or 4 or 1? It's a arbitrary decision with good reasons, which I can describe later. Academic age, well, different patterns of publishing, different disciplines. It's also kind of limitation. Finally, samples versus population. In big data, there are no samples. These are all populations, just everyone. So it's a different statistical story. And one more thing, globally and nationally. We did both type of studies. Globally, however, some type of information is just not available. We don't have gender. We have to infer gender. We don't have date of birth. Globally, we have it nationally. So we have to use a proxy of career age, of professional age. We can't use national discipline classification because there are too many countries. So global studies have their own limitations. We use proxies, we infer some data. Generally, we need to be aware of it. Finally, in national studies like Poland, we have real scientists with national IDs, just real scientists, perfect data or near perfect. And in global studies, we have just Scopus over IDs. We infer some data. We have proxies. So it's kind of limited approach, but when we know the limitations, we can do it. There are trade-offs. We need a trade-off to test new ideas. Well, what we are basically doing. So summary and conclusions. We've been working in academic profession studies with surveys and interviews for decades, and it's fantastic. We'll be using it for decades. But the new data types, they come from governments like registries of scientists or other type of data, and they come from corporations like Scopus or Web of Science. We can complement and combine all this type of data as long as we have access. It's another limitation, access and cost of access, but still, it's possible. Finally, we need to repurpose what we receive from governments or what we receive for corporations, because they didn't do it for us. They collected the data for themselves. So limitations again. But anyway, access to longitudinal data, imperceptible patterns. This is all great promise for academic profession studies. I can say it's enormous promise. We've been doing 6 strands of research in the past year and a half, and we are only beginning to produce the results. So anyway, the conclusion is we can sharpen our insights into the academic profession, not really into higher education, not really into all higher education personnel, but into publishers in science, or just scientists publishing scientists. So precision detail, this is what is clearly seen. And the final note is perhaps we have globalization. Science and higher education also is one of the most globalized spheres of human activity today. And the idea of global academic profession studies is coming somehow naturally. We can't compare really mathematicians in Germany with mathematicians in France, or American, whoever, astronomers with German astronomers. We need a kind of moving out of national containers and moving towards perhaps the containers of disciplines. A global approach is I call it a new kid on the block, some potential, some opportunities still to be discussed. I will be happy to discuss these opportunities, the limitations and issues today. it's always fantastic to hear, you know, critical opinions. So I'm leaving this the rest. I'm stopping sharing the slide, and I'm open to any discussion and questions. Yes, thank you so much.
Well, thanks, Marek. That's a great deal in that, and thank you very much for providing it for us. I'll be waiting for some questions to come into the chat, but meanwhile, I'll start with a couple of my own, if I can. I was going to ask you, you know, what don't we know from these big data studies? That's kind of spurious question. I think a more useful question might, and one that opens up possibilities for other researchers who are not working with big data, is what are potential contributions to science and academic profession studies of other kinds of research? I'm thinking, for example, of the role of qualitative studies, interview-based approaches, case studies, that kind of thing, in enabling us to understand what's going on, particularly in these more subtle aspects of, say, differences between people at different career stages, gender differences, and how this interplays with disciplines and so on. I mean, what if you were a qualitative researcher sitting alongside Marek Kwiek, looking for opportunities to supplement his work and expand our knowledge thereby, what would you be doing?
Yeah, well, excellent question. I'm still thinking how important survey data and interview data are today. I would never say there is any like new data replacing the old data and new approaches replacing old approaches. There are some questions they can be asked only for surveys, and most answers can be received to these questions only for surveys. All those, you know, professional or beliefs or perceptions or feelings type of data. Are you satisfied with your work, or what were the problems when you had your maternity leave, etc., etc. But I believe somehow in the complementarity of this type of data. When we know from big data, for instance, then that old scientists in STEM, women, are really isolated, the natural follow-up would be, okay, let's interview, let's talk how they survive. I mean, we know that the percentages were like 90% to 10%. It's changing, but still, we could talk to young academics and we could talk to old academics and compare their, you know, their fighting in the hostile environment. You will never see it through the data, but the data give you an initial idea. There's something like decreasing isolation in science when you are younger, but you are old, you had to fight, you are a survivor. I'm always, but you know, I'm somehow coming from surveys, so I know all the answer from surveys from the past 10 years, and I'm thinking what new and what larger pictures can be received from big data, and I'm seeking answers I couldn't find in surveys, but still complementarity is the word. But also when I look at those people from different, you know, camps sitting here and maybe listening also to me or to you, Simon, certainly there is a quant-qual division in thinking about science. It's absolutely clear, and people from interviews will never fully want to understand big data, and people from big data will be somehow unwelcome to studies based on, you know, 12 or 20 or 30 interviews, even though we know the fruits of both approaches: complementarity and self how to call it, okay, complementary. That's enough.
Yeah, no, I really agree with you. I think it's really important to valorize, and, you know, all these different lines of investigation, if you like. I mean, I think the challenge is defining a common problem, you know, between these different approaches, because the approaches tend to determine how we see the problem. And yet there's probably something missing there sometimes in terms of the fluency and combination of understandings of the problem itself. And I think in that process of working out what we think the questions are, we can make better use of complementarity, which is, you've quite rightly emphasized. I mean, my own impression is that in studies of science is that you can't tell much about values and purposes of the work unless you get to talking to people directly. So interviews and surveys are much more useful there. And in the big studies, there's a tendency to infer purposes and values, which is really the researcher building in their assumptions about likely values and purposes and then interpreting the data thereby, like the emphasis on preferential attachment, which is quite persuasive, I think, but not sufficient to explain a lot of researcher behavior. But that's tended to become de facto the explanation for many people who are working with the big data sets. But when you actually interview people, you find that they've often got more high-minded, values and purposes in view when they're conducting research. So I think qualitative dimension does have an important role to play. I was intrigued by what you said about mobility and about discipline-based containers, because it struck me that, an awful lot of people in Europe are moving around between countries, between sites, but working within the same discipline, broadly speaking, as they do so. And we do limit ourselves substantially by our dependence on national designation as our primary way of defining where people are from and what they're doing and so on. Now we've got a number of people coming in, and I'll bring in Celia Whitchurch first to reward her for being the first to suggest that she would like to speak in the chat. So Celia, please come in now.
Thank you, Simon, and thank you very much, Marek. I mean, I think this is really important work. As you know, I'm a qualitative researcher, mainly looking at academic careers these days, but obviously we need to take cognizance of these large data sets. And I think trying to bring in a comparable dimension is enormously ambitious. So I'll be very interested to follow your work. I mean, the questions that have come up in the work that William Locke and I have been doing shortly to publish our book is basically around the increased mobility and fluidity of academic careers. I'm thinking, for instance, of early career researchers who may move in and out, may move out of higher education, back in again. I mean, when we talked to people in detail, we found people had different ambitions and different ideas about how they were going to develop their careers. And of course, the question of teaching only academics is a very important one, particularly in Australia and US and UK. It may not be elsewhere. So it's really just to corroborate what Simon was saying, and to stimulate some thinking about how we might bring the two together. I mean, very difficult to do on a comparable basis. It's difficult enough to do when dealing with HESA data in the UK, I can tell you, trying to match that data to what one finds out in interviews. So, but thank you very much. It's important to keep the big data in mind, I think, as well as the small data.
If I can answer briefly, Celia. Well, it's important probably not to try to really, combine the two approaches. It's like I'm inclined to take theories and thinking from the tradition of sociology of science, from the Merton School to the Cole brothers, until recent studies, just traditional stuff. And this stuff is coming from surveys and from interviews, and I value it enormously. But what I'm thinking is that we can somehow test those, assumptions and theories. Let's consider the Matthew effect and sacred spark theories of productivity. They were based off, say, a few hundreds of observations here and there in mathematics, in astronomy, in different STEM areas, and we have fantastic theories which hold for half a century. And I did a Polish study, very detailed, the one published in Higher Education, when we followed scientists for 40 years, all their publications. And we were thinking, is it really true that once you are highly productive, you will be always highly productive? And once you are bottom productive, you will be always bottom productive? It's a very narrow approach. It's just publications. It's only publications, just one, simple metrics, but it's damn true. So when you take big data, in this case, Polish data, and global data, 1 million applications, you really see your chances for being highly productive today are six times higher when you are highly productive assistant professor or highly productive associate professor. So we somehow come to the roots, which were not really database, well, somehow database, but still big intuitions. And we can test it and say, yes, it works, or say, it works in some areas, but not in other areas. It was a nice idea, but it was only an idea. So this is what is fascinating. It's not really maybe providing huge questions and huge answers. Maybe, modestly just testing a few of older theories, interview-based, etc., etc.
Thanks, Sin, and thanks, Marek. And can we now bring in Envy Varghese? Hi.
Well, thank you very much. Thank you very much for a very good presentation, Professor Marek. My question is, when you are presenting the data, I clearly see that among the younger generation, gender parity is moving in the positive direction. Can I infer whether or not intergenerational inequalities are declining based on the Scopus data in terms of gender equity and inequality? That is one question. The second question, did you make any effort to see that these changing patterns over a period of time, since you have such a large data set, in relation to the enrollment patterns in the disciplines that you have studied? Is there a relationship, positive or negative, relationship between the gender parity or non-parity in terms of enrollment in these disciplines and in terms of the research that is reflected through the Scopus? Thank you very much.
Yes, thank you very much. Just one by one. The first question was, is the parity increasing? Are we moving toward parity? I would say based on this data, which are purely publication-based data, there is an inflow of women to STEM sciences. I'm not studying, social science and humanities because it's much more difficult. There's not reliable data about this disciplines. But in STEM, there is an inflow of women. We can see, except for the Big Four. You see the difference, except for the Big Four. Another question is why, but it's not a large-scale database question. It's more maybe a smaller scale question with empirical data from different even disciplines like psychology. Is it changing? It is, except for the four disciplines, there are more and more women. Well, the question is, are they the same women? So when we see 40% of young women and then 40% of young women 5 years later, are these the same women? This is a question of attrition. We are trying to really work on this question right now. So what's happening to young men and young women, and is attrition from science, leaking out of science, much higher for women? Looks like it's higher. So even the percentages look nice, it may be these are not exactly the same people. For this, we need longitudinal studies. You take people, 1 year, say 2000, and you follow every person year by year, and some of them disappear. Are they massively women? I would say in some areas, these are much more women than men. So this is about parity. Generally, right direction, but still, as I told you, with current trends, 100 years needed for full parity. But we know it's just an exercise. Things go faster than trends show. And another question was enrollments into disciplines for students or enrollments into faculty. If we talk about faculty, certainly the more women around, more chances to have even more women around. If you look at medicine, it goes like this: high slope, more and more and more women. If you look at those mathematized disciplines, no changes at all. No changes at all. And if you want to link it to enrollments, you can't do this. I mean, you can do this, but then you work on the basis of individual institutions. So we have to link every person to institution and have enrollments data available for European countries like ETER data. We have full enrollments data from ETER dataset, but not really globally. I mean, it can be done if you link it to students. But we don't do it. We focus on academic profession without really going back. But you're right, we need to be thinking about enrollments in studies, in mathematics and astronomy, et cetera, to think about enrollments or coming to the academic profession. That's a very interesting suggestion. I believe it's useful to do this type of exercise. enrollments in STEM sciences, enrollments into academic profession, and the relationship, if any. I believe there may be some, or maybe huge correlation, but we didn't study this so far.
Thank you. Thank you.
And thank you both. I'd like to bring in Michael Holscher now. Michael.
Yeah, thank you, Michael Holscher from the German University of Administrative Sciences, Speyer, and professor in higher education and research management. Thank you, Marek, for your very impressive and great idea. You already addressed a little bit of my question with regard to the problems you addressed in the end of your talk. I was wondering what you did to check or control the validity of your data just to make it better, to improve it. And for example, did you compare some of your results with selected reliable traditional survey or administrative national data, and what were the results? And regarding complementarity and Simon and Celia's comments, I see also a great potential for combining qualitative work with parts of your data to get a better impression what the data really tells us. So
Yeah.
did you make checks?
Yeah, thank you. We did a lot of checks before we moved out with the Polish study. So we had all Polish data, all national registry, Scopus data, other publication data, institutional level data, all types of data. So before moving out with this, we did a lot of checks. Well, it works fine. It works pretty fine on a national basis. When we think globally, 38 countries, and normally computer scientists would do 180 countries. It's far more difficult to say it's correct for Germany, but not so far correct for France, and possibly correct for Australia. I mean, it's a scale which is much more prone to some, well, disturbances, to some limitations are different in different countries. So when you discuss all those limitations one by one, you can see that they refer to different countries to a different degree. So I would say at the moment, well, we compare our data certainly with what Elsevier is producing on the gender front, and what OECD is producing in this studies of in this data on academic personnel. But still, we have this specific approach, say not really scientists, but scientists publishing at least three publications. It's a different, well, population. Not everyone, but so we have limitations which somehow make it impossible to make valid comparisons. If I'm saying, for instance, and it's valid, 70% of scientists today in STEM are doing kind of medical related research and research in biochemistry, molecular biology, etc., etc. It's true. I mean, you can verify all steps in the work, but still it sounds surprising. But then you think, okay, it's just cited references. It's one of the approaches. If you don't look cited references, but you look some other approaches, it may be different. It's an issue. I would say it's an issue because it's somehow not replicable. You can do either the same or take different assumptions, and then the story is different. I agree. But I believe in powerful stories also.
Thanks, Michael. Thanks, Marek. Our next question is from Matthias Montero. Matthias, are you there, please?
Hi, Marek. Thank you, Simon. And thank you very much, Marek, for your insightful presentation. I'm Matthias, and I'd like to ask about interdisciplinary research, because it strikes me about your presentation about how to deal with multiple disciplines. I mean, because it seems to me that research articles are assigned by the journal index categories, let's say Scopus discipline categories. So I'd like to ask, how can big data help to operationalize interdisciplinary research? How can we deal with that? Because I read a report that struck me about the an increasing pattern of interdisciplinary research globally. So if you have an approach, it could be rather helpful. That's my question.
Thank you very much. I would say excellent question. Let's remember, we are focusing in these studies on scientists, people, academics, not really publications. So we apply to every person his or her discipline. The answer is we don't apply multidisciplinary disciplines. We can't do this. We even cut all multidisciplinary journals from our study. To give an example, if you published your every single publication in Science or Nature, all these big journals which are multidisciplinary, you will be counted who you are based on your cited references. But if all your references come from Nature and Science, etc., we can't define you. You move out, you are cut out from the study somehow. So it is an issue. But we believe, still looking at Simon, we believe we belong to some disciplines. We don't believe we are multidisciplinaries, whoever. I'm a social scientist. Simon is probably a social scientist too, but we are not multidisciplinaries, whatever. Our publications can be multidisciplinary, but we, so far, I believe we are not. So it is an issue, I agree. It's hard to study this interdisciplinarity unless we do it based on people. Like you take scientists from different disciplines and you see how they collaborate. You take thousands of mathematicians with thousands of astronomers and you see any type of joint work or something. It's possible, technically relatively easy and good to do. But when I think of scientists, people, academic profession, it's hard to say Marek or you are multidisciplinaries or interdisciplinaries. It's not even a word for this, like mathematician or astronomer. But it's a great question. An important issue. Yeah, it's a very important issue.
I think whenever social science
Thank you
goes,
very much.
whenever social science goes into the public domain, it's very difficult to put a disciplinary label on it, isn't it? Because we draw fairly freely from different methodologies, theorizations, and interpretations when we seek to make our work about common problems and relevant to policy and practitioners. I've got a couple of more questions, Marek, if you don't mind. You've been doing this kind of work for what, about a decade, I think?
Academic profession, yeah, about a decade, yeah, more than a decade.
And the big data work, almost that long?
Big data is, I would say 3-4 years, maybe 4 years.
That's the most recent period,
and
yeah.
Massively 2 years, but still work in progress. I would say on average 1 year to 1.5 years is one strand of research for us. We are on a learning curve, so it's difficult. It will be faster, I believe. That
helps me in asking my question. I was intrigued by what you said about longitudinal studies and how valuable and important they are, and really hope that you can go further in that direction. But tell me, just thinking longitudinally for a moment, I mean, in the 10 years or so that you've been working on the academic profession, what are the main changes in that time that you see in activity and behavior? And second question, how has your big data exploration changed the way you see those things?
Yeah, first, I'm taught and learned and really rooted in survey data, and survey publications. So I'm not really rooted in computer scientists writing about anything. I'm coming from, so this is my roots. So I'm naturally inclined to find the problems I've been discussing for years and moving to a new data set. So I'm studying productivity, I'm studying scientists, I'm studying, this type of data, this type of analysis I've been doing anyway in the past decade. Longitudinal data are perhaps the most challenging and also the most interesting. We are never able to think of ourselves as academics from a perspective of 40 years, what I did for Poland. 40 years, year by year, the same person, the same ID, and productivity classes, changing when you move up the academic ladder. This was the most surprising and the most interesting, really big story. Now we are repeating it for OECD, but still the Polish story is probably most compelling because we have full real data with, well, national registry IDs. So longitudinal latitude is something was not possible. Well, we're pretending in surveys, we're doing longitudinal studies. We took one survey, well, 10 years ago, then I take another survey, 100 Polish professors, okay, done this year, and we pretend it's longitudinal. No, it's just different cohorts, different people. We can't follow people generally over time easily. We can do it, but it's too expensive. So one of the most perhaps promising avenue is this longitudinal approach to us, who are everyone active in publishing. This I see as enormously promising. Well, and interesting also.
Another question I have is about your next moves, you know, your future work. I mean, where are you going next? What's the main lines of inquiry you're developing over the next year or two?
Yeah, it's hard to say really where you're moving when you are on the move anyway. I'm on the move. Still, it depends on resources, people around, basically also people around. But what we have been doing and what is almost ready. Well, I was worried and thinking a lot why women are somehow collecting much fewer citations. So we did this huge OECD study about men oversighting themselves. I was thinking about myself, okay, what is the percentage of my self-citation, self-references in my reference list across my, my life, and compare it to, any women of the same age, etc., etc. We did it large scale. And when you look at the percentages, it's like men consistently have 8% self-cited references in the past 30 years, and women have 6%. 30 years pass, long period, people come and go, and it's always this huge difference in self-citation rates. So this is almost finished. Then another issue is, well, these highly productive people who have always been fascinating me, for 15 years or 10 years or something. Once you are highly productive, will it continue? Persistence in high productivity. We finished a study of 300,000 scientists for the past 30 years in 38 countries. And looks like in OECD, it's even more radical than in Poland. In Poland, it's, 50% of people are always highly productive. Upper 10%, 50% total. In OECD data, in our data sets, it's 60 to 65%. So we are even more, I would say, we are just highly concentrated. Top performers are highly concentrated. Once you start a top performer, you get the money, you get the grants, you get the people, personnel, young people, all this stuff, and you keep being highly productive, except for special cases. In Poland, we studied 2,300 people for 40 years, and there were only 100 people who really changed their classes. 100, 4%. Normally, your chances to change your productivity class are, I would say, slim. The first few years it's very deterministic. You need to talk to people, you have interviews, etc. It's another issue. But we do large-scale data. The data show, the picture. Other people talk to people, do interviews, maybe we do, but we don't have time. Others take this line of thinking and say, oh yeah, there is something in it. When you talk to people, it's something. The Matthew effect works. The sacred spark mechanism works. And Marek shows it in big data. Not really published, but it's almost finished. So this is my approach, Simon. I don't know if it's worth it. It might somehow disengage me from the higher education research community, which would be a disaster. But I see many colleagues around with big names who do similar stuff using big data with their doctoral students and young people around. So I hope I will not be disengaged or cut off from my area, because it would be a pity.
Oh, I don't think there's any danger of that, Marek. There's a lot of interest in your work, and might be more interest now than there ever has been. So there you are. The big numbers have got a compelling power. to engage all of us, and that coverage, you know, that those populations, those whole populations, it's compelling. I mean, it's interesting, isn't it, about highly productive people? It's a topic of great, you know, we could talk about at length, but if they're made and not born, they're clearly made early in most cases. Patterns are set. And there's almost you'd like to look at the difference between people who are highly productive from their late 20s onwards and those who come in mid-career. I think that might be an interesting comparison. Folks, we've reached the end of our time, and it's time to thank Marek and thank all of you for participating, and your excellent questions have added to the webinar. Our next webinar is coming from Peter Sandler, who's Peter Mandler, who's a professor of history at Cambridge, and he's going to talk about the way in which the school curriculum has swung, and its take up by students has swung towards STEM and away from the humanities. So it's an historian talking about the decline of history, or is it? I think we'll find there's more to the story than that. Peter is an engaging and very effective presenter, so we look forward to his webinar. That's going to be on Tuesday the 18th. We're going to take a break for Easter from here on until the week after next, Tuesday the 18th of April at 2 o'clock in the UK. We look forward to seeing you then. Thanks very much again, Marek. We of course hope to have you back next time you've got a big story to tell us, and I trust that you will approach us when you're ready. Look forward to that. And to everyone, thanks again, and bye for now.
Bye bye. Thank you so much. Take care. Thank you, everyone.